Hello, everyone. My name is Alex Sherrod. I'm with Precision Pipe and Products, and I'd like to welcome you as we begin part 2 on our discussion of culvert rehabilitation and the slip lining process. As we begin, we're going to take a look at the following questions. What is trenchless rehabilitation? What are the common trenchless rehabilitation methods? What is the slip line installation process? And review of a project case study. So what is trenchless rehabilitation? Well, it takes maximum advantage of the remaining usable structure or pipe so that the pipe is returned to its initial condition or better. These methods have less impact on the public as they can be done inside the hose pipe without the need to close down the roadway. Trenchless rehabilitation is appropriate when the culvert has lost structural integrity, but it has not completely failed or collapsed. So what are some of the most common trenchless methods? The vinyl wrap, the cured in place liner, spray-on liners, as well as rigid liners. So why do we rehab the entire structure and not just patch the bottom invert? Well, as discussed in part 1, corrugated metal deteriorates with age. When the invert rusts, there are 3 things that can happen. First, the bedding and backfill under and around the pipe is no longer supported and is allowed to enter the stream of water, and the water washes away any material that can be dislodged. Secondly, because part of the circumference of the pipe is gone, it is no longer able to retain the soil in the position as engineered for a stable structure. This affects the ability of the pipe to resist the weight above, and their circumference begins to change. And lastly, if water is allowed access to the annular space between the culvert and the surrounding soils, unchecked pressure can build and eventually force the culvert sections to separate, further degrading the performance and safety of the structure. For these reasons, paving of the eroded invert is typically a band-aid fix, and it does not properly address any structural issues that come from the loss of the invert. So there are several factors to consider when determining which is the best trenchless rehab solution for your project. They include understanding the flow capacity, the design life or period of time for which the alternative solution is estimated to maintain structural integrity, increased structural integrity, or the ability of the rehabilitation method to increase the overall structural integrity or strength of the culvert, adaptability of the solution's ability to be expanded upon or altered in the future, the total estimated costs, including contingency and design fees, as well as materials and construction, the environmental impact, and the amount of detrimental impact to the surrounding environment and the effects upon the stream due to alternative implementations, community and traffic disruption, which is the amount of disruption to traffic flow, business operations, and the daily life of the community, the estimated construction time for any alternative to be completed and constructed, the permitting difficulty or the amount of difficulty and labor related to obtaining proper permits for the alternatives construction, and finally, contractor availability or the overall availability of relatively local contractors to construct the alternative. So Precision Pipe and Products, we have a great decision-making matrix available at our website, www.infrasteel.com, which you're going to take a look at, which is a tool that aids in assessing which reline and rehabilitation solution is right for your project. So you'll see it looks just like this with 3 tabs down at the bottom to guide our decision-making. And we'll first start over here with defining our priorities and our options available to us. So step 1 tells us to assign a number between 1 and 10 for each criteria, with 10 being the most important, 1 being the lowest, 10 being the highest. And you can see we have all 10 of our different project criteria listed here with a short description on the right. I'm going to fill in this information with some numbers to show you how this matrix operates. Once that's done, we can scroll down to step 2. We have the option to add, remove, or edit any of the following rehabilitation options. So we have listed here an infrasteel smooth wall carbon steel slip liner, a arch smooth wall steel pipe replacement, a round smooth wall steel pipe slip liner, a polyurethane spray liner, a tunnel plate liner, aluminum structural plate pipe arch, which would be a replacement method, cementous spray liner, a reinforced concrete slip liner, and a smooth wall polyethylene slip liner. And we do have room to add different options, but we will go with the ones we have currently listed. So once this is in place and we've got our weighted numbers assigned to what criteria is most important to us on the project, we can click over to tab 2, where we will see this sheet here. And our directions state that this is our workspace, everything within our yellow box. We can edit each cell with data from our analysis of each rehabilitation method. And so from these boxes to the left to the right, again, we see our criteria, and we have the ability to manipulate these cells here. These 3 require user input, and so that would come from the engineer or project manager who is assessing which rehabilitation method they want to go with. And then from cells E through J, we have a drop-down menu that allows us to weight how effective these rehabilitation methods are at accomplishing the desired criteria or end state. So we can see, just as an example here, we will go to round smooth wall steel pipe, it's a slip liner option, and we can see that increased structural integrity, we'll put that at a high, or a weight of 4. So you can see that some of these cells are empty. And again, I'm going to input some user data to see how this affects our evaluation of the different methods. We're going to jump over here to the increased structural integrity on our polyurethane spray liner. We're going to put that as a low as far as that method's ability to increase the structural integrity. Community disruption. Well, with an aluminum structural plate pipe arch replacement, we would have to dig up the existing roadway. And we're going to say that is an extreme disruption to the community, having to cut and replace the roadway. And again, over here on permitting difficulty, we'll put our polyurethane spray liner at a moderate difficulty and our cementous spray liner at a moderate difficulty. Over here with contractor availability, under our infrasteel smooth wall carbon steel slip liner, we'll put that at a moderate. And with our round smooth wall steel pipe, common material. A lot of contractors know what they're working with. We will put that at high. Total estimated construction costs. We'll put this project at $650,000. And we will put our construction contingency down here for our smooth wall polyethylene slip liner at $60,000. And finally, our last cell to be filled in, our design and construction administrative costs for our RCP slip liner at $70,000. So over here on the far right column, we can see where our total project costs are tallied, taking everything into account from cells K through M. However, the data that we inputted into our prior cells, B through M, will be tabulated on our evaluation summary tab. So once all this data is inputted, that's all we have to do. We'll click over to our evaluation summary, and we will see what the data gives us as far as our evaluation. So first, we'll take note that the score of the criteria is calculated using the rank Excel formula. And the score will be between 1 and however many of the options we're going to be considering. In this case, we have, again, all the ones listed there. So 2 or more rehabilitation methods may have the same score in these columns if they were tied from the same data entered on the Evaluate Our Options tab, which is here. So again, our InfraSteel slip liner total estimated cost, that had a priority of 6, and this received a score of 4, so our total weighted score would be 24. And we can see how that is done and calculated across all of our columns here, all the way across. And at the end, we receive a score based on the weighted value of our criteria and where these different rehabilitation methods weighed. We'll get the total score, with a higher score being the best, meaning that it could be the best possible fit for your project. And again, this is available on our website, www.infrasteel.com. Just put in your email and this gets sent straight to your inbox. This is a unbiased tool, and we developed this as a method to aid in deciding which rehabilitation method would be most suitable for your project. So now that we've reviewed different factors to consider when assessing your rehabilitation project, we will jump forward and discuss what is the slip line installation process. Well, it begins with cleaning and dewatering of the host structure, and bypass pumping or the construction of cofferdams are common methods to dewater the host pipe. We can see bypass pumping being utilized in the above picture, as well as the construction of cofferdam to allow the work to take place in a dry environment. And cofferdams can be used in conjunction with bypass pumping methods if there is a high likelihood of a storm event that would overrun the dam's ability to hold the waterway. There's a great picture of bypass pumping being utilized, and we can see that this concrete bridge culvert has actually been rehabilitated with a smooth wall carbon steel slip liner that is actually tapered at the end to aid in control of the rate of water flow through the structure. Our second step in the slip line installation process is the installation of the slip liner to include the welding or joining of joints. And the installation of a slip liner usually occurs by either pushing or pulling the liner into place. We're going to watch a short clip here of a liner being inserted into the host structure. Here we have a smooth wall steel liner being pushed into place with a standard piece of equipment or track hoe. And you can see that that liner is actually being slid on top of some channel iron, it looks like, as it's being inserted into that corrugated metal pipe culvert. Our third step in the installation process is the grouting of the annular space, which is the space that exists between the culvert liner and the existing structure. And you can see here a great cross section of a slip liner, the grout filling that annular space, and the existing corrugated metal pipe on the exterior. So grouting can be accomplished utilizing pre-installed grout ports in the top invert of the liner or by horizontal grout injection methods. Different slip line materials may require a specific grout PSI at the point of injection. So the above photos show two slip line pipes in the state of Maine. The figure on the left shows a proper grouting finished product. The grout is uniform around the entire circumference of the pipe. However, in the picture on the right, the liner pipe is resting on the hose pipe. Now, this can result in point loads on the liner in the future. And also take note that the voids are gathered in the grout, and this must be avoided to help ensure the longevity of the slip liner. So as mentioned in our introduction, we're going to review a project case study that consists of two corrugated metal pipe culverts that were rehabilitated in the state of New York. The New York State Department of Transportation and the St. Lawrence County Department of Highways worked together utilizing a shared service agreement to streamline the completion of these two culvert preservation projects. By doing so, they ensured long-term motorist safety and the lowest taxpayer costs possible. The state's project was located under Route 12 in the town of Hammond, New York. The existing structure was a corrugated plate arch pipe that was installed in the 1960s. It had a span of 131 inches and a rise of 81 inches, with a deteriorated invert that was completely rusted through. The culvert was located under 2 feet of cover from the roadway, and from the pictures, you can see that the bottom invert had experienced severe degradation due to corrosion and abrasion. So New York State Department of Transportation structural engineers ruled out the option of paving the invert due to the concerns regarding the structural integrity of that type of repair. The only other option that the state had for a solution would require cutting the road and replacing the existing structure. This method would have taken significantly longer to complete and had a much higher estimated cost. So moving forward with a smooth steel rigid slip liner, the project was completed in 2 weeks with a total cost of $85,000. This provided a cost savings of $275,000 when compared to the cut and replace alternative. From the pictures, we can see that the crew is working the inside of the slip liner, inside of the hose pipe as they join the liner sections together. And then we can see them utilizing a grout truck to pump in grout to fill that annular space through pre-installed grout ports that we can see the top invert of the liner. St. Lawrence County's project was located under County Road 47. With similar construction to the state structure, this corrugated metal pipe culvert measured 103 inches by 71 inches, and it was located under 16 feet of cover. After assessing the feasibility of open cutting the road to remove the failing culvert, the county determined that it was not a feasible option due to the following reasons. It would have required 6 weeks of road closure, and required traffic to detour 24 miles. The additional travel time for emergency vehicles and motoring public due to the detour. And lastly, additional costs to relocate an existing utility line that was located in close proximity to the culvert. The estimated cost to cut the road and replace the existing structure was $217,000. By slip-lining the structure in tandem with the New York State Department of Transportation, St. Lawrence County was able to complete the project in 12 days with a total material and construction cost of $75,000. This resulted in a direct savings of labor and material of $142,000, and the additional cost savings of the detour to the traveling public was recorded to be $399,000. By working together, both organizations were able to expediently and effectively rehabilitate the failing structures via trenchless slipline methods. The two culverts were repaired quickly and economically without an interruption of emergency vehicles and other traffic. The slipline construction methods used for these two projects saved the taxpayers of New York State and St. Lawrence County over $816,000 in total construction and impact costs. Now we're going to watch a short demonstration on the benefits of the slipline installation and rehabilitation method. So in summary, what is trenchless rehabilitation? It takes maximum advantage of the remaining usable structure so that the pipe is returned to its initial condition or better. What are the common trenchless rehabilitation methods? Common methods include a rigid slip liner, cured in place pipe, spray-on liners, or vinyl wrap. What is the slip line installation process? Clean and dewatering of the host structure, installation of the liner material, and finally grouting of the annular space. I'd like to thank everyone for joining us in part 2 on our discussion on culvert rehabilitation and the slipline process, and hope that you've been able to take away some information on factors to consider when assessing what rehabilitation solution is appropriate for your project. Again, I'm with Precision Pipe and Products, and my contact information is listed here. If anyone has any questions regarding this presentation or trenchless rehabilitation methods. Look forward to seeing everyone again soon. Thank you.